Polyethylene, also known as PE, is one of the most widely used polymers in the world. It is a thermoplastic polymer made for ethylene monomer to polymerization reaction. Polyethylene is popular because it is lightweight, flexible, chemically resistant, and easy to process. Polyethylene plays an important role in many industries such as packaging, construction, automotive, electrical, and medical applications. Common products made from polyethylene including plastic bag, bottle, food packaging, films, water pipe, and containers. The properties of polyethylene depend strongly on the polymerization process during its production. Different polymerization methods can produce polyethylene with different density, molecular weight, and mechanical properties. This presentation focuses on the main polymerization process used to produce polyethylene, including bulk, solution, emulsion, suspension, and gas phase polymerization, along with their advantages, disadvantages, and application.
Hello and welcome. My name is Muhammad Auluddin Bakti bin Adnan. Today I'm going to talk about bulk polymerization in polyethylene production. Let's start the video. Now let's go to the bulk polymerization. My name is Muhammad Auluddin Bakti, just like I said before. Now let's go to the lesson outcome. After this presentation, viewer will be able to describe the bulk polymerization method as applied to polyethylene production. Second, explain the fundamental principle of bulk polymerization for polyethylene. 3. We'll be able to give a detailed advantage and disadvantage of using bulk polymerization for polyethylene. And finally, viewer will be able to provide example of products and application where bulk polymerization of PE is used commonly. Now let's enter to what is bulk polymerization method as applied on polyethylene. Bulk polymerization is a polymerization process, one of polymerization process, but it's actually not that popular in high production industry because how annoying is it to use. Anyhow, it's a polymerization method in which ethylene monomer is polymerized directly without using solvent, water, or dispersing media. In polyethylene production, this method relies on pure ethylene with only small amount initiator or catalyst added to start the controlled reaction. Now, let's go to the fundamental principle of polyethylene production. Ethylene is subjected to high temperature and pressure using catalyst. This monomer concentration is very high since no solvent is used, just like we said in this part, where it said, where is it? We said no solvent is being used, right? Exactly. Without the use of solvent. So it's basically what is it? Now this lead to a fast reaction rate and formation of high molecular weight. As polymerization process, the reaction mixture become highly viscous and make it difficult to remove it. This is why I said no one use it in production of polyethylene, because it have a lot of problem and a lot of flaw to be used, and it's definitely not uneconomical, which why we're going to explain the advantage and disadvantage of bulk polymerization of polyethylene. Now the advantage is it's actually a very simple process design. It also has high purity, which means no solvent removal needed. It also have high monomer conversion. Finally, it also have low risk of contamination from solvent of water because it doesn't use it. There it is, right? Now, just because it has the advantage doesn't mean it's good. It also has disadvantage. It also has poor heat dissipation, high viscosity, mixing difficulty, difficult to control molecular weight and reaction rate. Finally, safety risk go overheating. Now let's go to the other part. Now let's go to the application and products of bulk polymerization of polyethylene. Now onto the application. It's being used in laboratory and academics research. It's also used in pilot scale testing of polymerization process. It's also being used in production of specialty or experimental polyethylene. Now the product is very interesting because it's correlated with the application. For example, the small quantity of high grade polyethylene usually being used from the application of laboratory and academic research. Now, experimental polyethylene sample for testing usually related to the pilot scale testing of polymerization process. Now, finally, specialty polyethylene material for research purposes, of course, is being used in production of specialty or experimental polyethylene. That's all for this part. Let's go to another part.
Assalamualaikum and very good evening to everybody. Today, I want to explain about solution polymerization of polyethylene and emulsion polymerization of polyethylene. And today, I'm not alone. I have my own personal assistant, Larry. So, how about Larry? Can you show the slide? Thanks a lot for Larry for showing us the slide. Without further ado, let me explain the slide for you. Now I'm going to explain about the solution polymerization of polyethylene. The process starts here where ethylene gas is stored and fed directly into the system. At the same time, the organic solvent such as hexane is applied from the solvent tank. Both streams enter the stirred reactor alongside with the catalyst plus initiator to activate the reaction, to start the reaction. Alright everybody, let's move on to the next phase in the stirred reactor. So inside the reactor, everything is single liquid phase. You can see I already highlighted. Why is it single liquid phase? Because the solvent keeps the monomer and polymer dissolved when they are dissolved, this allowed very good control of reaction, temperature, and molecular weight distribution. So that's why they are kept into the single liquid phase. Moving on to the next phase is this after polymerization. So the mixture on the stirred reactor will flow onto the flash separators. In this flash separator, the solvent are separated from the polyethylene product. The separated solvents enter the distillation column here. This is the distillation column. And for what they enter the distillation column, this is for the purification process. You can see here, purification process. And after the purification process is done, they will recycle back into the process, which reduce the operating cost. The solid polyethylene is removed, dried and collected as a pellet. This method is commonly used to produce high quality HDPE and LLDPE for pipes, films, and containers. Alright, for this method, ethylene gas first passes through the compressor and then enter a water-based system. This is the water-based system. Water, surfactant, and initiator are mixed to form an emulsion before entering the polymerization reactor. So before they enter this, they will need to form an emulsion. So what's the difference between solution polymerization of polyethylene and emulsion polymerization of polyethylene? So a key difference here is the reaction happens inside a tiny droplets called micelles. So micelles. In the zoom image, we can see, this is the zoom image. Yes, we can see that micelles made from surfactant molecules. The hydrophobic tail face inward, trapping the ethylene monomer inside. Meanwhile, the hydrophilic face face the water. Okay, hydrophilic head, I'm sorry. And then the initiator enter the micelles and trigger polymerization. The polymer chain will grow inside these micelles and form a latex slurry, which is a milky liquid containing small polyethylene particle. And then latex will pass through a separation and dry unit. So they will pass through this, and then it will be the final product, whether it will become a PE latex or powder. It depends on the factory needed. And alright, next we will see what is the key principle, the advantages and the disadvantages, and the daily product that is being made by the solution polymerization and emulsion polymerization. First, the key principle of solution polymerization is a homogeneous reaction system where the monomer, the catalyst, and the polymer are all dissolved. Secondly, organic solvent acts as a heat transfer medium, and the third is on go on a moderate temperature. For the key principle of emulsion of polymerization is aqueous medium. The surfactant and emulsifier to stabilize the micelles is also a water-soluble initiator, and the result is in a polymer. Moving on to the advantages and disadvantages of solution polymerization. For the advantages is it has an excellent temperature control. It's also easy to control the polymer microstructure, and is suitable for high performance polyethylene grade. For the disadvantages is it high cost due to the use of the solvent, additional solvent recovery and purification steps, and environment will may be affected if solvents handling is poor. And for the emulsion polymerization, the advantages is excellent heat dissipation, is environmental friendly, and produce fine polymer particle. For the disadvantages, it is not suitable for large-scale polyethylene production. It is also low monomer solubility, and it will limit reaction rates. Lastly, surfactant removal is a difficult thing to do. And the products that have been made from this reaction is, for the solution, LLDPE film. Maybe we see on the packaging or the stretch wrap, on the food. HDPE pipes and highly performance plastic container. Maybe Tupperware, not Tupperware, the legend. And for the emulsion polymerization, is polyethylene latex coating, water-based adhesive, and surface-modified polyethylene dispersion. Alright. In summary, the difference between these two is the reaction medium, where solution polymerization use organic solvent to produce a high-performance PE with excellent control. Meanwhile, emulsion polymerization use water and surfactant, but is limited due to the solubility. Each method has its own great and disadvantages, so it all depends on the final use and the application. That's all from me. I will pass it to my friend.
Hello and Assalamualaikum. My name is Muhammad Zairul Azim bin Ibrahim, and you guys can call me Zahirul. So for my part of presentation, I will give you about suspension polymerization for polyethylene and comparative analysis of polymerization methods. So here we go. So for my first point, I will explain suspension polymerization in polyethylene production. Suspension polymerization is a method where ethylene monomer is broken into small droplets and suspended in water. Water does not dissolve the monomer, but it helps to control temperature during the reaction. So, for basic principle, the polymerization reaction happens inside each droplet, and this forms solid polyethylene bits. A suspending agent is used to prevent the droplets from sticking together. One major advantage of this process is good heat control, because water can absorb heat efficiently. it also produces uniform polymer particles, which are easy to handle and process. However, this method also has disadvantage. The system needs extra chemicals like stabilizer, and after the reaction, water must be removed, which increase processing steps. The polyethylene produced usually has good strength and consistent particle size, making it suitable for injection molding and packaging products, such as containers and plastic components. Next, I will compare the 5 polymerization methods used in polyethylene production. So, here we go again. First of all, bulk polymerization is simple and produces high purity polyethylene, but it suffers from poor heat control and high viscosity during reaction. Solution polymerizations offer better temperature control, but it requires large amounts of solvent, which increase cost and purification steps. Also, emulsion polymerization is very effective for producing small particles, but it is rarely used for polyethylene because removing emulsifiers is difficult. Suspension polymerization, which I explained earlier, provides good heat control and uniform polymer bits, but it requires additional steps to remove water. Lastly, gas phase polymerization is the most important method for polyethylene today. It does not use solvent or water, making it economical and environmentally friendly. It is widely used to produce HDPE and LLDPE for packaging, pipes, and containers. In conclusion, while each method has its own advantages, gas phase polymerization is the most suitable for large-scale polyethylene production, whilst suspension polymerization is useful for producing PE with controlled particle size for molding applications. So, that's all for me. Let's move on and go to the next slide.
Gas phase polymerization is one of the most important and widely used industrial method for producing polyethylene. In this process, ethylene monomer react in the gas phase without the use of solvent or liquid monomer. The polymerization takes place inside a reactor, usually a fluidized bed reactor, where solid polyethylene particles are formed directly from the gas phase monomer. In gas phase polymerization, ethylene gas is fed into a reactor containing a solid catalyst such as zinc-granata or metallocene catalyst. The reactor operates at relatively low pressure and moderate temperature. The catalyst allows ethylene molecules to join together and form long polyethylene chains. As polymerization occurs, solid polyethylene particles go and are continuously removed from the reactor. Since no solvent is used, separation and purification steps are simple compared to another method. Gas phase polymerization offers several advantages. First, it does not require solvent, making the process environmentally friendly and cost effective. Second, energy consumption is lower because there is no need for solvent recovery. Third, the process provides good control over polymer properties such as molecular weight and density. Lastly, it produces high purity polyethylene with minimal post-treatment. Despite its advantages, gas phase polymerization also has some limitations. Heat removal can be challenging because the reactor is highly exothermic. Poor heat control may lead to reactor overheating. In addition, the process requires precise control of reaction condition and catalyst performance. The reactor design is complex and requires carefully operated to avoid particle agglomeration. Gas phase polymerization is commonly used to produce high-density polyethylene HDPE and linear low-density polyethylene LDPE. This type of polyethylene have high strength, good chemical resistance, and excellent durability, making them suitable for industrial and commercial application. Polyethylene produced by gas phase polymerization is widely used in everyday products. Example, including plastic bag, food packaging, film, detergent bottle, household container, pipe, and industrial packaging material.
In conclusion, polyethylene is an important plastic used in everyday products. Different polymerization methods are used to produce polyethylene, and each method affects the properties and application of the final product. Both solution, emulsion, suspension, and gas phase polymerization each have their own advantage and disadvantage. Some methods offer better control over polymer properties, while others are more suitable for large scale and cost-effective production. Gas phase polymerization is widely used in industry because it's efficient and environmentally friendly. Understanding this polymerization process helps manufacturers choose the best method to produce polyethylene for specific use and industry. That's all. That's the conclusion. That's all from me. Assalamualaikum warahmatullahi wabarakatuh.